Today, everybody, we are focusing on the properties of logarithms. The properties of logarithms are very similar to the properties of exponents. Right now, the only properties we're going to use today are the product property, the quotient property, and the power property. If you don't know those, you might want to write these down and pause the video right now. Oh, we're making a video. Right now, they paused the video. Now, what we're going to do right now is we're going to go to problem number 2. And it says, I need to take the natural log of 27,000 and I need to convert it to just natural log of 10 and the natural log of 3. So the very first thing that I would like you to do is this. Is say, this is equal to the natural log of 27 times 1,000. That's the very first step. Now, there is a method to my madness, people. There's a reason why I chose the number 27, and there is a reason that I chose the number 1,000. Emily, can you tell me why I chose the number 27? Because I can see that you understand that is of importance right now. You can break it down in threes, that's right. So technically, I could rewrite it as 3 cubed. Now, Raymond, Mr. Smart Guy over there, all right, what could I change 1,000 to? That would be 10,000, but just 1,000 becomes 10 to the power of 3. So you were just one group of 10 off, just one group of 10 off. All right, now, this is easy. Next thing we got to use is we use the product property. Now, for those of you who don't know the product property, I'm going to write it down right here. Product property. It's not funny yet, okay? But here's the product property. If I say the log of any base, A times C, that will break down to the log base B of A plus the log base B of C. This is the product property. Very similar to our exponential property called the product property, where you have the B to the power of A times B to the power of C. You're allowed to add those together. Yes, Miss Cheshire, how may I help you?
Would you send Raymond to Emerson's office so they can go and donate, please?
Absolutely.
He needs his picture ID.
All right, he's going to go save a life. We're going to save a life. And that'll be immortalized forever, Raymond. Good job. All right, go save a life, Raymond. Now, everybody, Josiah?
Yes, sir.
Understand, you could break this down to the natural log of 27 plus the natural log of 1,000.
You don't want to do that.
But we don't want to do that because we actually want to say the natural log of what?
3.
3 to the power of 3 plus the natural log of 10 to the power of 3.
But don't you flop that over?
We're going to be doing something because now we've done the product property. We have to do power property because we have the power. Now, for those of you who don't understand the power property, the cool thing about logarithms is if you have an exponent right here and right here, you are allowed to take those and move them out in front. So we would rewrite this as 3 ln of 3. 3 times the natural log of 3 plus 3 times the natural log of 10. And that's your answer. Now, some of you right now may not realize, okay, why does the power property work? So this is what I'd like you guys to put into your journal. Okay? We started out with what? Natural log of 27 plus the natural log of 1,000. And we said, Josiah, that 27 was the same as saying 3 times 3 times 3, right? And we also said that 1,000 was 10 times 10 times 10. Now, if you really wanted to expand this, you could say the natural log of 3 plus the natural log of 3 plus the natural log of 3 plus, you don't have to do this, I will suffer for you. Okay? Here is everything. This is called expanded, okay? To expand something means it's like getting longer and longer and longer. This is another way of expanding it, all right? If you have 3 times 3 times 3, what does that get us back to? 27. 10 times 10 times 10 gets us to 1,000. Well, what's a more condensed way of writing this? How many natural logs of 3 do we have? 3. So that's why you're allowed to write 3 natural log of 3. How many natural logs of 10 do we have? 3. Everybody, we are not going to use the power property here. This is going to be your example of the quotient property. If you desire to know how the quotient property works, write it down. If you still want to be clueless, please watch another video. Now, the quotient property takes this concept of b, say, to the power of 7 over b to the power of 5. What are we allowed to do with those exponents? Yes, you're allowed to subtract them and get b squared.
So
In a very similar way, yes. Go ahead, say.
is it 10 on
Yes, but you have to write this. The natural log of 10 minus the natural log of 9. These mean the same thing. Remember, the quotient property states if you have a logarithm of any base and you have a over c, that's the same thing as saying log base b of a minus log base b of c. I'll put this in parentheses so you know that's the order. Okay? What goes first? What always goes first? What's on the top? What always goes in the next? Whatever's in the denominator. So the numerator always goes first. The denominator always goes second. Order matters. Now, Haley, we are good with this because it said we needed to make it everything in terms of the natural log of 10. But this is not the natural log of 3. So is there a way I could convert this 9 to a 3? What would you say? 3 squared is right. So right now we've changed 9 to what? 3 squared. Now that we have 3 squared, what's the final step that we do? We have to take the power property and move it to the front. So your final answer is the natural log of 10 minus, and what number am I going to put out in front of the natural log? 2. This number here goes in front. So the natural log of 10 minus 2 times the natural log of 3 is how you would write it if you were only allowed to write things in terms of the natural log of 10 and the natural log of 3. So here's what I want you to do. Check out the calculator. Type in the natural log of 10 divided by 9 and press enter and see what decimal you get. You get that decimal. Now what did we say our answer was? We said our answer was what? Natural log of 10 minus what? Minus 2 times the natural log of 3. If we did it correctly, what should we get as our answer? Right. The exact same. And if you notice, does this decimal right here match this decimal? Yes, it does. That means we got it right. If it didn't match, that means we did something wrong. All right. What I'd like you guys to do right now, on your own, All right? I want you guys to attempt to do problem number 4. Now, problem number 4 looks a little bit more complicated. So, I'm going to give you guys some hints. So here we go. Just so you guys know, 3 to the 4th is 81. 3 to the 5th is 243. And 3 to the power of 6, 729. 10 to the 3rd is 1,000. And 10 to the 4th is 10,000. Remember, I want all answers right now. All answers need to be in the natural log of 3 and in terms of the natural log of 10. Good luck. This is where you would pause the video if you're watching and try it on your own. See what you come up with. All right, if you're playing this, you're checking your answer right now. So listen, what you should have done first is write the natural log of 729 minus the natural log of 10,000. But then you saw my clues, and you were like, ha! I'm going to change that 729 to what? That's right. And then you're like, I'm going to change 10,000 to what? And then you're like, either you told yourself this or you didn't. You said, I have the power property. That's right, the power property, which means you can take this 6 and do what with it, Jade? Where? Which way is over there? On the other side of what? That's right. That's better instruction. Good job. So we're going to say 6 times the natural log of 3 minus. What am I going to do with the 4?
You're going to bring it to the front.
Of what?
Of ln.
Thank you. Of the natural log. So we're going to say 4 times the natural log of 10. Not Ellen DeGeneres, all right? Hopefully we didn't break any copyright rules there. So, your final answer, in terms of the natural log of 3 and the natural log of 10, is 6 natural log of 3 minus 4 natural log of 10. I'm glad you all were able to survive that problem. Now, what we need to do next is we need to go down to problem number 6. Now we're going to be understanding, wait a second, there's just not numbers, there's variables. All right? So we're going to look at problem number 6. Okay? So write that down in your journal. This one's a little bit more complicated. There is a key thing you need to write in your journal, and that is this. If I say the square root of x, that is the same as saying x to the power of 1/2. Here's your basic rule. For any number raised to a certain power and an index, by the way, this is an index and a radical, this is a power, in rational exponent form, that will be x to the power of m divided by n. This is called, this is a quick little review for those of you who haven't done this in a while, this is called radical form. Right? This is called rational exponent form. I think those of us who grew up in the 80s understood this a lot better just because we use the word rad a lot more than you guys do. Okay? And radical. Right? Yeah, radical. So, right now, everybody, if you ever want to go from radical form to rational exponent form, what do you need to know? You need to know the index, you need to know the power. So the first thing I want you to do in problem number 6 is do this. Put ln of x squared over 3x plus 2 raised to the power of 1/2. Even though you can't see it, the index of this is a 2. Even though you can't see it, all of this together is technically raised to the power of 1. So even though you can't see it, it's still there. Because you can't see the wind, doesn't mean the wind's not there. Now, we're going to break this down and we're going to use the quotient property next, everybody. We're going to use the quotient property. And the quotient property allows me to say the natural log of x squared minus the natural log of 3x plus 2 right here. And what is that raised to the power of? 1/2.
But then you can bring
Ooh,
the 1/2 to complicate.
that's right. So Josiah realizes, haha, that 2 right there is a power. What am I allowed to do with that power? Move it in front. What am I allowed to do with this power? Right there? Move it up front. So what would our final answer be? Totally expanded all the way out. There you go. That's your final answer. We're doing one more example, and the rest of them you have to do on your own. Okay. One more example. Last problem you want to do it, put in your journals, problem number 7. In problem number 7, what you need to look at is you need to realize that this right here, 2x to the power of 3, is being multiplied to x plus 1. Now the very first rule we're going to use is what's called the product property. This should be in your journal. You should already have this. You just need to know how to apply it. Okay. So right now I need you guys to understand that the 2x cubed is your x, and the x plus 1 is the y. So I'd like you to separate those, if you would please. Separate those correctly. So if we wanted to separate it correctly, we would write log base 2 of, I'm going to put also in parentheses, 2x cubed plus log 2 of x plus 1. So the 2x cubed is right here. The x plus 1 right here. So we use the product property to separate those, all right, to expand it. Now, there's only one thing we have to do on this problem. That 3 right there? What am I allowed to do with this 3 right here? I'm allowed to move it up front using the power property. So our final answer is 3 times the log base 2 of 2x plus log of 2 log base 2 of x plus 1. There's everything expanded. What I want you guys to do on your own is to expand all the rest of them on the front page. Take your time, work through it, get them done.
I don't know what you said about the little number in the corner of the screen.
Okay, so for example, I'm going to give you one more example. Okay, so Josiah, this is just an example. I think it's on your page. If I say log 2, let's say I have a radical x plus 1 like that. And then I have, what if I said I had a 3, okay? And I said this was x plus 4. Let's say I wanted to expand that. Well, the first thing I would do for this one is, this is a quotient property, so the first thing I would do is say log 2 of the square root of x plus 1 minus log 2, open parentheses, radical x plus 4. That's what I would do. Now the next thing I would realize is that this right here is actually x plus 1 to the power of a half, because that technically is, that index is a 2, and what's inside of this is raised to the power of 1 minus log base 2 of, and this index is a 3, and this right here technically is raised to the power of 1, so I'd make this as a 1/3. So my final answer to Josiah would be 1/2 log of 2 x plus 1 minus 1/3 log of 2. And this is just an example. This is not one of your problems. Okay? But this is a good example of how to convert what? How to convert radical form to rational exponent form. Okay? So for those of you who are still struggling, here's 2 more examples. If I said that's a 3 and that's an x and that converts to x to the 1/3, if I would have said that's a 3 and that's an x squared, then that would be x to the 2/3. And so on and so forth. Good luck, and I hope you learned a little bit about logarithmic properties.